Hello everybody, I'm Mark Tewksbury, your host for this program. Our goal is to reveal the methods and materials that go into the everyday products that you see around you, from toothpicks to computers to airplanes. If you thought you knew something about these items, you might be in for a surprise. There's a whole world of things waiting for us to discover on how it's made. It all starts with a cocoon. Making one with worm silk is the work of a butterfly caterpillar, and it matures within it. It weaves its cocoon in 3 or 4 days using 2 saliva threads from its lower lip. Remarkably, a single cocoon yields up to 1.5 kilometers of silk thread. In this program, aluminum foils, snowboards, contact lenses, and bread. Oh, the magic of aluminum foil. You can use it to heat something up in the oven or keep something cold in the fridge. But how do they transform that big piece of aluminum into this thin little foil? The manufacture of aluminum foil requires the repeated thinning out of a large block of aluminum. We begin by melting ingots of 100% pure aluminum in a natural gas furnace. These ingots, called pigs, are essential in alloys with zinc, titanium, and silica. It takes 3 to 8 hours to melt 27,000 kilos of aluminum in this remelting furnace, which operates at 750 degrees centigrade. The fusion temperature of aluminum is 660 degrees centigrade. A portion of aluminum is poured into this small mold to make a sample. Solidifying in just seconds, the sample allows for testing to verify the contents of the prepared alloy. This trough is used to transfer the aluminum from the remelting furnace to the tapping well. Molten aluminum runs in a movable trough located above the tapping well. At this stage, impurities are filtered out in special receptacles. The molds are cooled with water to accelerate the solidification of the molten aluminum. Ingots are unmolded and are ready for milling. Each ingot is massive, measuring 4.4 meters in length, 1.4 meters in width, and is 45 centimeters thick. It weighs a whopping 7,500 kilos, so it has to be handled by overhead cranes and placed on special plates. This crust-removing machine removes 3 millimeters of the ingot's thickness. Impurities are eliminated to achieve a perfectly smooth finish. All traces of the liquid used to cool the decrusting knives have to be eliminated. The many steps in the thinning of the ingot begins. The aluminum block is crushed by the hot mill rollers. Temperatures in the rollers are between 455 and 540 degrees centigrade. Pressure on the ingot is continually verified by a technician. If too great, it's lowered and the technician then adjusts the pressure. The heat is so high that the ingot risks sticking to the mill's roller. To prevent this, everything is cooled with a liquid that's 95% water and 5% oil. Starting from a thickness of 45 centimeters, the ingot becomes increasingly thinner with each pass-through. Depending on requirements, the ingot will go through the machine between 12 and 16 times. The ingot now measures 7 centimeters in thickness. It has to get down to just half a centimeter. At this stage, the ingot is 5 centimeters thick and measures a little over 9 meters in length. This conveyor transports the plate during its milling stages. The ingot has now become a 5 millimeter thick sheet. It is sufficiently thin to proceed to spooling, where it spools onto itself before being sent to the cold rolling mill, where its thickness will be reduced still further. The aluminum sheet has become very thin now and risks being broken by the tension needed for cold rolling, so the sheet is doubled to avoid this breakage. One final reduction in the mill, and the sheet will have the thickness required by the customer. A liquid coolant is used to prevent the foil from sticking to the rollers. Since the edges of the foil sheet are lightly damaged and crinkled, a knife removes a 1 centimeter thin strip. Finally, the roll is cut to the desired width, and one huge ingot has produced foil measuring 12.7 kilometers in length.